Welcome to another episode of the Digital Native Podcast. Today's guest, we have Lakshmanan. Lak is the head of data analytics and AI solutions for Google Cloud. He's also the author of Data Science on the Google Cloud Platform, which is published by O'Reilly Media. Lak, thanks for joining.
Oh, thank you, Ryan. It's great to be here.
So, really excited to have you on the show, Lak. I think folks are going to be interested to hear about your team, what you guys are working on, and how you engage with customers. To get us started, tell us more about your background and how you got into technology.
Yeah, I mean, my background is that I'm an engineer, electrical engineer, and I've been doing machine learning. But back then we called it pattern recognition. Pretty much all of my career, I started out developing machine learning algorithms for weather prediction. So if you've ever been in an airport, probably we've not been in an airport very recently, but if we've been in an airport back before Corona, you probably saw images, radar images. And those images basically are collected from radar. There are about 160 plus weather radar in the United States. And all the radar gets collected and then composited and used to basically do a lot of decision making on things like, do you fly the aircraft? What heights do you fly them in? It's used for also in the private sector. Do you, for example, on golf courses, whether you let the game go on or you close it down for stadiums. It is also used for a lot of severe weather forecasting. So if you live in the Midwest, you probably saw the person on TV screaming about how the storm was about 15 minutes away. All of those things are basically based on data analysis and machine learning, and that was basically what I did for a long time. So that's what my background is.
So tell us about your journey to Google. You're based up in Seattle, the Seattle metro area. How did you end up at Seattle, and how did you end up at Google? And what kind of companies had you worked for prior?
Oh, okay. So as I said, I worked in weather, and so. All my career, I think, until about 4 or 5 years ago, was working in the federal government. So it was basically working in what's called a cooperative institute. So this was quasi-academic. I worked in a university lab that was part of the federal government. And along the way, I would do consulting for a number of companies. And one of the companies that I had done consulting work for was a company called Climate Corporation that did precision agriculture. And the idea was to tell farmers, provide farmers guidance on what to plant, when to plant it, what seeds to do it, and importantly, how much did it rain on your field. And that was what I came in to do. I took 1 year sabbatical, moved to Seattle, and built a team that basically built a lot of the underlying weather processing for doing precision agriculture. And the year was up, and they said, "Hey, sabbatical's done. Let's go back home." And my family looked at me like I was crazy. They're like, "You can go back to Oklahoma. We're staying." The Pacific Northwest, it just gets to you. So at that point, I was like, "Okay, we need to find something else to do." And that was when, I was like motivated to find something else, the next thing. And what had happened at Climate, at the startup, was that I got my first experience of the cloud. So we basically, the way that we built our rainfall systems was that we had to go back and process about 15 years of radar data and carry out a number of rainfall prediction algorithms on it and create an ensemble of all of them. This involved processing multiple terabytes of data many times. And you can do it one of two ways. You can do it on 100 machines, and it can take multiple years to do it. Or you can do it on thousands of machines and get it done in a matter of weeks. And that's the cool thing about the economics of the cloud, right? Whether you basically spend 100 hours on 100 machines, or you spend 1,000 hours on 10 machines, it's going to cost you the same thing. So why don't you get it done as fast as you can? And that was what turned the switch for me. That cloud was going to fundamentally change the way we did large data analytics, because the economics is a no-brainer. You want to do things as fast as possible. The second thing that had happened was, this was around 2014, was machine learning itself was changing. It used to be that if you did machine learning, you had to write all of the filters yourself. So I started out writing image processing filters, and I have and every time we wrote a filter, we would write a paper about it and do a peer-reviewed journal, publish it. It was research. And now you want to train a pattern recognition model on images. You basically upload images to the cloud, and you click a button that says train, and the filters get created for you. And that's because you have this thing called convolutional filters that were invented around in the 2012, 2014 range. And these are automatically tunable things. So rather than you having to write the code yourself, the machine learning essentially learns the filter weights. And that was the second thing that had happened. And so I was like, okay, if I'm going to go do my next chapter of my career, I need to find a place where I can combine these two amazing things, these amazing improvements in machine learning and these incredible capabilities of the cloud. And really, there's just one choice if you want to be doing both ML and cloud. And that's why I landed up at Google.
No, thanks for sharing. And I think that's a good segue into your team at Google. You've been with Google now 4 years, or I think going on 4 years.
This is my fourth year at Google. Yeah, so I'm, in terms of Google Cloud, that's like I'm a veteran. People say, you've been here a long time. I say, yes, I've been here 4 years. And from the time when I started, I think Google Cloud was very small. Our entire cloud Next fit into a single conference room at Next. We had a ballroom, and we basically run Next there. And then we did not have Next in person this year, but Next in person last year was multiple buildings all over the Moscone Center, etc. It's huge.
Over 30,000 people attended. I mean, it was pretty grand.
Exactly. The growth has been incredible. Yeah. So my team, you asked me about my team. So my team my team is called Solution Engineering. And what we do is that we build software solutions that, in my team in particular, we build software solutions that involve analytics and AI. So to kind of set some context here, mostly what Google Cloud does is we build products. We build things that you can go to the GCP console, you say, I want to use BigQuery, I want to use Dataproc, and we give you a platform into which you bring and you write your code. You write the thing that you want to do to build it. So we provide the platform, you bring your code. But lots of times people say, well, the problem that I want to solve is not something that is so unique to me. It is a more common kind of thing. And wouldn't it be nice if instead of me having to go build all of the libraries and for myself, why don't you give me something that is more readily usable? Right? And that's where a solution comes in, where we basically take together all of our products and we put them together to solve the kind of common problems that people deal with. As an example, one of our solutions is called the Contact Center AI. Contact Center AI is essentially this idea that when you call a call center, the kinds of things that happen in a call center all fall into a very common set of rubrics. If you call into a call center, the first thing is, are you calling about something like, are you open today? What hours are you? Are you going to be open on Saturday? Is the branch open? Can I make a deposit at this ATM? Right? Those are the kinds of common questions that you can often answer in an automated way. Right? So the first part of a call center is to basically say, what are these things that are fundamental, that are very static, that we can immediately address? Then you basically say, okay, no. The customer has a question that needs a human intervention. And then the call center software needs to then take them to the human. And when the call center agent starts answering these questions, you want to populate the screen that the call center agent is answering, so that it knows what questions are being asked, and the knowledge base comes in and it's getting populated. All of these are common. What I just told you is common regardless of whether it's a call center for a retailer, or the call center for a bank, or the call center for a public sector agency. They're all the same. So what we do is we put together this reference architecture and say, this is how you build it. Here's a whole bunch of products that help you get there. And then that gets finalized and fine-tuned for the specific use case. So that's what a solution is, and that's what my team does.
I think consumers everywhere who have dealt with call centers and dialing in, trying to get someone on the phone are rejoicing, including myself. I think about a time in the probably not so distant future where we'll tell our kids about, hey, when we used to try to call XYZ company, this is what would happen. And it wasn't a pleasant experience.
Absolutely. Again, the whole idea behind the call center is to basically improve the customer experience by making sure that when you reach a call center agent, that agent has all the information that they need to resolve your concern immediately. The idea is to basically do it in the first go. But in order to do that, we need to arm the call center agent with all of the material from across the different parts of their organization so that they can answer it, right? This whole idea of, I'm going to now transfer you over to this other department because they're the ones who know how to do it, that should never happen, because we're bringing that information into the first person who handles you.
No, that's great. And as a customer, you get your Saturday back. So moving more towards kind of the landscape and what you're seeing, I think one of the common misconceptions I've seen from certain folks is, hey, AI, ML, a lot of this stuff is great, but it's just not there yet. The technology isn't there. Once they start using it, I think a lot of those misconceptions are turned on their head. How quickly is the landscape evolving when it comes to AI machine learning?
Again, I mean, it's always the case. I think what I like to say is it is AI until it works, right? And once it starts working, people say, "Oh no, that's not AI." Okay, so let me give you an example. Suppose I plopped you down, said Ryan, 10 years ago. This is Ryan of 10 years ago. I say, "Hey Ryan, one day you will basically be able to get into your car and tell a machine that I want to go to I want to go to Discovery Park in downtown Seattle," and the car basically starts telling you the direction to drive, tells you that there's going to be a lot of traffic on I-90, tells you to take Highway 520, gets you into Discovery Park, tells you where the parking is. You would have told me that is like impossible. That's like magical. That's AI. But Google Maps does it every day. Right? And at this point, we stop thinking that all of those components for everything from figuring out the traffic to figuring out your navigation directions to figuring out where parking is going to be available, all of those things, all of those capabilities are all part of this thing that is AI. But once it starts working, you stop thinking about it as AI. You start thinking about it as, okay, this is just logical, right? And similarly, right, if I had told you 10 years ago that you'd be able to basically, you don't have to catalog your army of photographs anymore. You just take your photograph, they'll all get automatically classified. Whenever you want it, you say, show me a picture of my kid when she was 3, and then you basically get the picture back. Or show me the picture of my kid when she was reading the book upside down, and the photo software basically finds all the pictures of your kid reading a book upside down. You told me that was crazy, right? But it's doable today. And it's the same thing when you look at voice recognition. When we talked about call center AI, contact center AI, that was not possible a few years ago, right? And I remember breaking my arm about seven years ago. I was bicycling, I broke my arm, and I couldn't type. So I tried to use dictation software, and it could not understand my Indian accent completely. It just didn't understand it at all. Fast forward to today, and I can basically speak into my Google Home and ask it to play. Spotify picks it up, plays like songs, and I'm asking for songs and names of titles that are, in Tamil, and that's fine. It's basically, I'm asking for 1970s singers from India, and it's able to understand me, and it's able to play the music back. The change is rapid, and we see that in the consumer space. You also see it in the enterprise space. It's just a little bit hidden because it's not these headlines, it's not the entire thing changing. It's all of the component and steps that are changing.
So moving the conversation to the enterprise, I think AI, machine learning, data and analytics are on everyone's top 3 list in terms of initiatives. Mm-hmm. What's top of mind with some of the companies that you've engaged with over the last year or two, and what are some of the trends you're seeing?
That's a great question. And whenever we talk to an enterprise, every enterprise is in a different state of maturity. We talk about the adoption curve of any technology, and AI is no different. It's a technology, and there is a difference in the adoption curve. So you have so let's look at the majority, right? The majority of enterprises that we see where they are in their adoption curve is that they're in the process of breaking down data silos and basically forming governance to start deriving insights from their data. It's one of those things that you have to get good at analytics before you can do AI well. And a lot of enterprises are in that transition stage where they've just now broken down their data silos. They're starting to see a lot of benefits from the large-scale data that they have. The reports that used to take a weekend to run, so they only ran it once a week. Now those reports take 4 minutes to run, so they're running it every hour. And because they're running it every hour, they're basically able to intervene in their business much more often. And because they're able to intervene in their business much more often, they're starting to see the benefits. And now they're coming and saying, wait a second, instead of me doing it once an hour, what if I do it all the time? But then the next question is, if I have to make decisions all the time, there's no way that I can stay on top of these decisions. I need to basically have an AI that I can manage, right? So you often talk in terms of a human in the loop and a human over the loop. And an enterprise that is basically on that adoption curve where they're moving from the point at which humans can no longer make every decision. Instead, they're now talking about making millions of decisions. And that scale switch is what needs to happen when you move to AI. And that is an adoption curve, right? So we basically see most companies are still in the mode of making thousands of decisions a year. They're not yet at the I want to make millions of decisions a day, right? But that is that transition switch that happens. It does happen for most companies, as we see. As they speed up the decision making, the switch goes on, and they say, well, instead of me making the decision on how many fish fillets to stock every one of my restaurants, let every restaurant make a decision on what it needs to order that particular day. And that is a switch that needs to change, right? From a centralized procurement process, which you can do with data analytics, to a more personalized, individualized decision making, for which you need AI.
I love it. It's almost removing the human and the bias and letting the data speak for itself.
I wouldn't say removing the human, though, right? Let's be very clear here. This is actually accentuating the human. Right? When you think about it, when you make a centralized decision, you're basically treating everybody the same. You're saying that my entire customer base is exactly the same, right? If you're saying that I'm going to stock every one of my stores in urban areas such that they all have 30% toothpaste and 20% shampoos and whatever, if you're doing that shelving, you're basically saying every urban area is similar. If instead you're able to say every store, every shelf, we can basically go ahead and make a decision of what is the best thing to put on that shelf at this time, right? And basically automate that stocking, you're able to be much, much more personalized for your customers who are actually going to visit that store. It is that change from making a decision that fits every store that you have to basically making a decision for every individualized store in every street corner, and you treat it differently.
No, that makes sense. And thanks for clarifying. Yeah. So this moving so quickly, what kind of opportunities does this pose for businesses? What kind of threats does it potentially bring to light for businesses?
And of course, opportunities and threats are two sides of the same coin. Right? If you are on top of the trend, it's a threat. It's an opportunity, right? If you're not on top of the threat, somebody else takes advantage of the opportunity. Now it's a threat. And the opportunity here is that you're able to build a business that is much more personalized, you're able to build a business that handles the long tail a lot better. Right? So that's the opportunity. The opportunity that AI brings to you is that you're able to treat every customer individually. And that is a huge opportunity, because a value proposition, when you can treat every customer as an individual rather than as part of a conglomerate of customers, the value opportunity is huge. But the threat is also there that if you are not able to figure it out, and if your competition does, everybody will move to the enterprise, this business that treats them like a person, right? Rather than as one of 1,000 people, right? So that's both the opportunity and the threat. And it's basically as customers and consumers though, this is the best place to be, right? As I mean, the way I think about it is I work for one company and I'm a consumer of thousands of companies. So from my perspective, right, it is great that I basically get a much better customer experience from every company that I'm a customer of.
No, it's great. I mean, you think about, a good example is buying a car. Let's say I'm going to buy a Jaguar. How do you treat a customer who has been a 20-year customer? He's buying his 5th or 6th Jaguar from us versus someone who doesn't know anything about a Jaguar.
Right.
Want to understand the basics. I mean, it's a very different experience that person.
And the idea is to treat them both separately, but both of them correctly, right? I mean, to the exact same point, right? If you as a 5-time owner of a Jaguar go in and the person starts telling you about the history of the Jaguar, it's a complete waste of both the salesperson's time and of your time. Whereas if I go in as somebody who is probably just kind of curious about a Jaguar, I need to be told a whole bunch more information. And this idea of being able to know the exact level of information, the exact level of hand-holding, and the exact price that I need to be offered and the exact services that I need to be offered are very different. Maybe I'm the kind of person who would go in with, we will take care of your oil changes for the next 10 years. And I'm like, hooray, right? I don't have to worry about maintenance, and I'm willing to pay more because I don't need to worry about maintenance. But maybe, Ryan, you're the fellow who likes to do the oil change in your driveway. That does not, you're shaking your head. Maybe you are, right?
That's not me. I wish. My wife wishes.
But you get the idea, right? So if you're the kind of person who does their own oil changes, that does not appeal to you at all. You would rather get the benefit in a different way. And that's what we mean by treat every customer personally, individually.
No, it's great. And again, a win for the consumer. So what do you think are some of the top challenges right now for tech and engineering leaders, in particular in this area?
Right. So the first thing and the biggest challenge that most enterprise leaders face is that currently their data is siloed between every department. Wherever the data gets collected, that person thinks that they own the data, and it's really hard for anybody else to get access to the data. But when you think about where's the best customer experience that you can provide, it inevitably lies in breaking down those data silos and bringing the data together. And not just bringing the data together, it's about providing the data in real time. The value of data drops considerably from the time it's collected to the time it becomes historical. There's still value in historical data. Don't get me wrong, right? There's a lot of value in data that's a year old, that's 2 years old, because you can use it to do a lot of analysis. Unfortunately, what people don't realize is that data that is only a minute old, right, that is usually about 10 to 15 times more valuable if you can make a decision of it at the time that you collect the data. Right? So we're not talking about just data collection and data silos. It's about making sure that you have that access of the data in real time, that the real-time data goes into dashboards, the real-time data goes into making AI-based decisions. The benefits come from 2 things. Break down the silos, get all your data, and get that data as fast as possible and derive insights from it as fast as possible. So that's basically where the technology bits come in. But then how do you do this? The way you're going to do this is by hiring the right people. And that's another big challenge that a lot of enterprises have, is that how do you hire and build teams that are capable of deriving insights from this data in as fast a manner as possible? And when they do that, there's another aspect to it. You can't just go ahead and take every bit of data, throw it together, because you run a lot of regulatory risks. There's a lot of privacy issues. And so you have to have the ability to assess the risk involved in data, assess the opportunity involved in data, and build the right products. So when you think about what are the top challenges, I would say there are four. The first thing is just technological, right? Solve the data problem. But second is people, hire the right kind of people. The third is risk management and governance. And the fourth and most important is building products that take advantage of these three things.
No, that's great. And you mentioned finding the right people. What do you look for in folks that you hire? How do you find those right people?
Right. So the thing about hiring is that, it is hard. It is super hard, because I think the way we've set it up is that we try to hire based on one of two things. We try to hire based on what the person has achieved in the past, right? We look at their resume, we say what their experience is, or we try to hire based on their interview performance. And they're both not so great signals, right? Because fundamentally, you're taking somebody who maybe have been successful in their previous environment, and you're going to put them in this new environment, and you want them to be successful in the new one, right? And so there is an impedance mismatch. And so what I always look for is somebody who's basically driven and can function in ambiguity. Someone who basically says, now I know what I want, somebody who's centered and says, I know what I want and I can drive to that. And I look for that ability more than any particular skill, because there's ability to basically take what you know, learn what you need to know, but execute. That combination is extremely important.
Yeah, that's great advice.
Having said that, I don't think I've gotten hiring right. It is a super hard problem.
Yeah. So last question, and kind of on what you're seeing in the market, and I want to talk a little bit about Google Cloud. But what are some of the common misconceptions that people have and customers have coming in when it comes to data and analytics, AI, machine learning? And then what are some of the mistakes that you're seeing being made?
Okay. I don't think I would see too many misconceptions. It used to be the case that people thought it was magic. It doesn't happen anymore. People are very, very, every enterprise leader that I talk to now is extremely realistic in what they believe can be done. And now they're coming in with their eyes wide open. So I don't really see too many misconceptions and too many mismatches in terms of what can be achieved. And what was the second question? Sorry.
Second question was, what are some of the common mistakes you're seeing?
Oh, what's the common mistakes that I'm seeing? Again, same thing, right? People are coming in relatively open-minded. The biggest mistakes are often the same mistakes that we've had in software for a very long time. It's basically when you start projects without adequate understanding of what the objective is, right? So the biggest problem that you see in analytics projects is basically saying, let's collect the data and let's see what's there. That never works, right? You've got to collect data with a purpose. You've got to basically build AI models with a purpose, and that purpose has to be driven by the business need and by the mission of your company. You have to know what it is that you're trying to solve. So the biggest mistake that I see is often people saying, I'm going to build a data team, we're going to collect all the data, and we're going to see what's in there. Well, you will never see what's in there, right? Basically, because most data that is just randomly collected is going to be arbitrary, right? There's not going to be much value in it.
You can't just build a data warehouse and insights will come.
Right. Yes, you have to know what you're putting in the data warehouse. Absolutely.
So that makes sense. So I've often heard a common theme I've heard across customers is folks don't know how good a lot of the products are that Google Cloud is offering when it comes to data and analytics. I've had several customers tell me, Ryan, why didn't you tell me X, Y, Z, or this product was this good? But would love to hear from you. What are some of the competitive advantages when it comes to Google Cloud and what we're doing in data and machine learning? And what are some of the things that make it unique?
Right. I mean, so let me break that down into two parts. One part is that in many cases, Google has faced a larger data challenges a few years ahead of everybody else. Right. So we've often had to deal with much larger data sets, faster data, etc., a few years ahead of everyone else. So when you look at our data platform, when you look at things like BigQuery, when you look at things like data flow, we basically have battle-tested things that work at large scale, that work very fast, and that basically give people access to insights and data processing capabilities that are frankly ahead of the competition wherever it is, right? So it's the quality of the platform. So it may be that, okay, yeah, can you process streaming data? Yes. Can I process streaming data? Yes. How much streaming data can you process? How fast can you process it? Can you do this at scale? Can you have a pipeline that is running for 4 years without dropping? Can you do a security update on those pipelines without shutting those pipelines down? Can I do an update of a pipeline and bring it back up? All of these are really hard in any other way.
No, that's great. And
so that's one part. That's the platform part. The second part is on the AI models. So that's another case where the quality of an AI model always depends on the amount of data that we use to train it. So when we say we have a vision API, what did we train our vision API on? Well, we trained it on every image that we crawled. And that's a fundamentally different set. So when you look at a translation model, you look at our natural language processing model, you look at our vision models, the quality of those is much, much, much higher than the equivalent products anywhere else. That's simply because we've had more data to train it with. And the quality of an AI model is better than the quality. It's basically driven by how much data that you have. And we have more data that we use to train our models with. And you see this also in the consumer space, where you look at the quality of our maps versus the quality of somebody else's maps. You look at the quality of our voice assistants versus the quality of somebody else's voice assistants. The same quality differences you would see on the enterprise side as well.
That makes sense. And I think people forget about Google's core business sometimes, and that, a lot of these technologies and products we've built to solve our own internal problems and to support, the 9 applications that we have that have over 1 billion users.
Right. And we're basically taking those same things and making them available through GCP. And so you get that same quality and scale advantage that the rest of Google, when you look at all of our Google consumer products, those quality differences that you see come over into the enterprise space as well. So I always encourage people to not just look at a checkbox. Don't just say, okay, this platform has this platform has this, let's just do a check. Actually look at the quality difference. How many objects, how many types of objects can you classify? If you do OCR, what is the kind of OCR can you do? Can you do documents that have 2 columns text in them? Can you do a document that has an Indian regional language in it? You start seeing those things and you say, okay, if it can be this good, if we can go all the way down to the 80th language and get amazing quality, how good do we have to be on like English or Spanish or German, which would be like one of the first 3 models that we've built, and we've had years and years of experience honing those.
No, that makes sense. So your team works with a lot of customers and folks, a lot of folks who aren't as familiar with Google Cloud. What are some of the first products that you recommend that folks kind of take a look at and getting started with? Mm-hmm. And what are some of these products enabling our customers to?
So BigQuery. That's my number one suggestion to anybody who does anything with data. I say, here, go to console.cloud.google.com, go to BigQuery, and just try it. Right? It's serverless, so they don't need to set up anything. They can just write some SQL statements. There are public data sets, so they can go ahead and do very simple queries on a public data set. And it has GIS capabilities, it has time series capabilities, it has machine learning capabilities. It's an awesome, awesome, awesome product. And it basically completely exemplifies the nature of Google Cloud, the massive scale, the serverless nature, the sheer interactivity of it. So if I had to suggest, like, start with one product on the analytics and AI space, it would be BigQuery. Start with that because that gives you a really good insight into what makes Google Cloud different.
No, that's great. And any compelling themes or events that you're seeing when folks?
So whenever we see people starting to use BigQuery, the compelling theme is exactly what. Oh my God, this thing is to my Hive thing is down, and BigQuery just finished it in 20 minutes, right? So there's always these things where things that they thought were impossible, we just handle out of the box, and it's just fine. And we see this over and over again. So that's always usually one of my delights, is taking BigQuery to a customer who hasn't used it, who has used Hadoop, who have used some kind of like Spark SQL or something, and they know things that don't work for them, and say, oh well, just try it. Right, and then it just works, and something that they thought was impossible, we get the result back in 15 seconds. It just blows your mind, and then the rest of the time it's like, okay, what else can I do?
Yeah, and that's where I think it gets interesting. I mean, you talked about hey, it's faster, it's cheaper. I mean, great. Yeah. But tell me about the business problems it enables me to solve. I mean, that's where we're really interesting.
Exactly. It's not about doing things faster and cheaper. It's about basically breaking down the barrier to the things that you thought were impossible.
Yeah, I love it. So any favorite projects that you've been involved with while at Google? And then you talked about, I imagine, BigQuery being a favorite product, but any other products that are your favorites?
Okay. So another product that I love, basically because that's a tool I'm in all the time, is Jupyter Notebooks. So the way you do Jupyter Notebooks on Google Cloud is Cloud AI Platform Notebooks, and I love it simply because, right, again, I have my own little machine on the cloud, and I can go to it anytime. It's in my browser, and I have access to my entire Python libraries and suite of products. I can run Apache Beam and Dataflow from there. It is my console to the rest of the Google Cloud Analytics space, and it's awesome. A new product that I'm getting really excited about are ML pipelines. So these are basically Kubeflow pipelines that is hosted. As long as it was all about, I had to learn Kubernetes, I was not too interested. I mean, I'm a data scientist. I don't want to learn Kubernetes. But now the Kubernetes is all abstracted away. And all I need to know is to be able to write Python functions. Even the Docker images get created for me. But I basically get repeatable experiments. I have a history of all the experiments that I've run, and I'm just loving it. Right? So the product that I'm getting really excited about is ML pipelines, because I'm basically able to see how continuous integration and continuous deployment are coming into machine learning, which is a fundamentally hard place for doing that. And repeatability in data science is very, very, very important. So the fact that we're solving it through these industry standard software tools makes life very exciting.
That's great. And any favorite projects you've been involved with while at Google?
The two most favorite projects that I've been involved with are both I cannot talk about externally. So it makes it relatively hard. Okay, one project I can talk about, right? We basically did a series of courses that was called Machine Learning for Business Professionals, and that was an interesting kind of thing where we basically said, let's take what we have learned about how do you build machine learning models and put them into a business. How do you manage the projects? What do you think about? How do you take advantage of how do you build? What do you buy? Right? And those things, and we basically put that together into a series of advice. And it's actually on Coursera and Pluralsight right now. Encourage people to go try it out. ML for Business Professionals. Love that course. But it's basically based on a bunch of these projects that I've done at different customers that I loved working on.
Thanks for sharing. So turning the conversation a little more personal now, last few questions. What's something you've changed your opinion on since you've been with Google when it comes to AI machine learning?
What have I changed my opinion on recently? I've changed my opinion on quite a bit. Okay. Very, very, very recently, and this is something that we published just a month ago, right? So at Google, we have this thing called 20% projects. So these are passion projects, things that you do. And as I think I told you at the beginning of the interview, I came in from weather. So having done that, after I came into Google, there are these teams at Google that do things that are related to weather. So I'm working with a research team that does things related to weather, and not 20% because now I'm pulled in a lot of directions. So maybe about 3 to 4%. So about a year ago, this group of really smart researchers in machine learning, they're based in Amsterdam, and they said, "Hey, Lak, can we have a conversation?" So yeah, sure. So early in the morning, reasonable time for both of us. Early morning for me, late evening in Amsterdam. We got together and they started talking about how they wanted to do an 8-hour prediction of rainfall. And I said, no, like this is not possible, right? The best that people have done is about an hour and a half. And these are all the reasons why. And this is how you basically measure how well you're doing. And these are the ways that you set up your current environment. And here's like ML models that have worked. I sent them a bunch of research papers that are in the field, etc. Said, okay, take it back. They read it. They came back, and we had more conversations. And then they said, hey, Lak, you'd be really interested. I said, okay, what? Well, we can get really good performance up to 8 hours now. I said, 8 hours? 8 hours? You're joking. It's just not possible. No, it was. Right? It was a really smart way of basically devising the way you build ML models. They take it something that you normally solve as a regression problem, solve it as a classification problem with bucketing. They had done set up the neural network structure so that it did upsampling as part of the structure itself, taken into account the way the spatio-temporal nature of the field is, and had the model learn it on its own on the fly, and did it on a really humongous amount of data. And yes, right, 8 hours. And that was just blew my mind that was possible. And yes, that's something that I thought was impossible, and it wasn't, right? It just needed people who could think about the problem in the right frame.
That's great. One of my favorite questions, what are some of the mistakes that you've made as a tech leader, and how have you evolved?
I think the mistakes that I've made mostly come down to not grabbing an opportunity when I should have, right? People always tell you, oh, you've got to be focused. You've got to learn how to say no. And the mistakes I've made are always in the times when I've said no to something that I should have been part of, right? And so these days, I've learned never to be definitive about, like, for example, this thing about the Amsterdam team and them saying, like, this is what I want to do. The way I framed it was, it hasn't been done before. Like 1.5 hours is the limit. This is how they did it. I gave them all of the information, but I did not say that this is impossible, right? So I tried. So I think that's the way I've grown, is that I've learned not the way I say it, I try not to kill dreams. Right? Don't be the dream killer, right? Because when you have somebody who's motivated, who wants to do something, don't kill their dream. And as a leader, as somebody who's been in the business for a long time, it can be tempting to say, I know better. This doesn't work. Go do this other thing instead. But so my advice is don't kill dreams, because if things go right, you're working with people who are smarter than you, right? And that's the ideal case. And you shouldn't kill their dreams. You should enable them.
It's great advice. And speaking of dreams, what advice do you have for young engineers who are just getting started, who are potentially passionate or interested in machine learning? What advice do you have?
The advice I have actually is ironic. It would be, don't set your heart on machine learning, because 10 years from now, machine learning will be old hat. It'll be something else. The things that I don't regret learning are from my undergraduate days, are basically learning how to think and learning how to learn. So always, right, your entire career has to be about, let me figure out what's next on the horizon and be open to those things. So don't be too tied up. Don't say it's going to be about machine learning and I'm going to go really deep on machine learning. The depth can come later. What you really need to focus on now, as a young engineer, is to basically be willing to learn new things and learn enough so that you can solve the problem and move on to the next problem. And over time, that efficiency of learning is more important than whatever it is that you know today.
Phenomenal advice. Last question I have for you. What's something folks might not know about you outside of work?
I play bridge. Do you know what bridge is?
I do, yes.
Did your grandparents play bridge?
I played with my grandparents. It's a great game.
Okay, awesome.
Yeah,
So I play bridge. I'm a tournament bridge player, and that's so. It's a funny thing. Is like the number of people who play bridge is a really small community of people. So wherever I travel, I'll find a local bridge club, and I'll go to their bridge club, and I'll get a night game in. So I've played in Galway in Ireland. I've played in London. I've played wherever I've traveled. I'll usually find a local bridge club and I'll go play there, and that's always fun because you're basically it's outside of the usual tourist circuits, and you go there and you get to meet local people and interact with them. And so that's my fun thing. It's also a way for me to go live the local life wherever I am now, because when you're in a business travel, it's just hotel room after hotel room, like cities blur together. But so this is a good chance for me to go out and be in the life of whatever city it is, even if the life is like a bridge life, right? No,
the bridge life. That's your next book. Well, hey, Lak, this was great. I appreciate you joining and being a part of the show. If I want to learn more about you, your team's work, where should I get started?
Oh, absolutely. So if you want to learn more about my current team and what we do, cloud.google.com/solutions, right? So solution engineering is my team. Before this, I was in a previous team where we built a lot of training courses. So if you want to learn more about Google Cloud, I really encourage you to go look at those training courses that our team built. It was part of a professional services organization. So cloud.google.com/training. And of course, right, shameless plug here, read my books, Data Science on Google Cloud Platform, and BigQuery, the Definitive Guide. So 2 books to get you started.
Absolutely. And I'll share those links in the comments as well as on the YouTube page. Lak, thank you again. Thank you so
Ryan.
much
This
for joining.
was a lot of fun.
Yeah, I had a great time catching up.